Good morning, Year 8 mathematicians, and welcome to another eagerly anticipated lesson on standard form. So if you can draw a line under the previous lesson's work, today's date, and the title will be Numbers Greater Than 1 in Standard Form. Okay, so on the screen, your do now task is I've put the name of some rather massive numbers in maths. On the right hand side, I'd like you to fill in the section where it says number of zeros. So for example, a million, that has got 6 zeros in total. And then you're going to put in brackets what that number would look like, written out, and you're going to work through to see how many of those you can fill in for me. Have a go at pronouncing them along the way as well, and then we'll go through some solutions in a moment. Okay, so hopefully we've got a couple on there, and you might then start to see the pattern of how these are named. Okay, so we've got a million, billion, trillion, and then they get into the rather bizarre quadrillion, quintillion, sextillion, and so on. Okay, answers are appearing there for you, and that's what the sort of thing you should have written out. Okay, and then the final one, see if everyone knows what a googol is. So it doesn't follow, I'll give you a hint, it doesn't have 36 zeros after it. This one has jumped a little bit. This one in fact has 100 zeros, and there it is painstakingly written out for you. So we've known from the previous lessons that this is not an efficient way of writing out very, very large numbers, and that's why we tend to use standard form for this instead. So we're going to develop that a little bit further in today's lesson. So we're going to explore what standard form means, follow the rules of standard form, and then be able to write very large numbers in standard form, like the examples we saw there in the do now task. So first of all then, let's have a look. When we say numbers greater than 1 in standard form, in the previous lesson we were perhaps looking at things like 10 to the power of 4. Now, it's not written there because it's not needed, but that really is 1 multiplied by 10 to the power of 4. But obviously anything multiplied by 1 is the number itself. So when we say 10 to the power of 9, we really mean 1 times 10 to the 9. For this lesson, when we say numbers greater than 1, that's the bit we're changing. So we've now got 5.98 times 10 to the power of 24. The powers and the 10 stay exactly as they are, but we've now got a different number rather than 1 in front of it. So I'm telling you, as a starting point, you may have seen this in science already, the mass of the Earth is 5.98 times 10 to the 24 kilograms. Okay, that's a little starting point for our hook today, and we're going to see if you can use that figure to suggest ideas for the next 4 that appear. So, there are 4 answers, and I'm asking what could the following measurements be. And along the bottom there are going to be 4 pictures. You're going to have a go at putting each of those into each of those boxes. So the mass of Jupiter corresponds to one of those sets of numbers in standard form. Same for Big Ben's tower, Usain Bolt, and then the YouTube views. Okay, so if you pause that and just have a little think where you think they might go. Okay, hopefully you've had a go at those. The top left one there, very, very large number. The biggest number we've got there on the screen is the mass of Jupiter. Then we've got height of Big Ben's tower. So if you remember, 10 to the power of 1 is in fact just 10. Multiply it by 9.6, we've got 9.6 times 10. So Big Ben's tower is 96 meters tall. Okay, sounds sensible. We wouldn't expect it to be any more than that. It's obviously not. I mean, if you thought 10 to the power of 1 was 100, we're looking at 960 meters. You start to think that's a little bit out. Okay. Next one, top speed of Usain Bolt, and the last one. Those of you who know the song Gangnam Style, incredibly addictive, and you may well now get that stuck in your head. So apologies if that has happened for you, but you're just going to have to live with that. 1.34 times 10 to the power of 9 was the number of views they got for that song. So these are the sort of examples you tend to see it in. It appears a lot in things like astronomy and science. So you've got anything that's measured in standard form, from the diameter of the Earth, the height of the Eiffel Tower there, And then you'll see a slightly different one there, 1 times 10 to the power of minus 10, the bottom right one, the size of an atom there. We're going to discuss those negative numbers in the next lesson coming up, but there's just a little show point there that we can do very large numbers we're looking at today. Next time we'll look at very small numbers. So standard form is a concise way of writing very large numbers, such as those that occur in IT and astronomy. For example, we want to write that incredibly large number out, much like we did for the do now task. Instead, we can write that as 5.3 times 10 to the power of 13. Now, there are some rules that we must know for standard form. Now, the usual format we look at is something like a times 10 to the power of n. And the golden rule is that the part a there, the first part, is always a number that is greater than or equal to 1, but it must be less than 10. So if we look at that very top number again, 5.3 times 10 to the power of 13. A there is represented by 5.3. We couldn't use 53 because that's greater than 10. We couldn't use 0.53 because that is less than 1. It must be between 1 and 10. Okay, and then the second part there, times 10 to the power of n, where n is the power that we're looking at, much like what we did in the last lesson, and that will always be an integer. It will be a whole number. So if you just make sure you've got that copied down so you know the rule, that bit I've put the sort of pinkish box around for the standard form there. Now, to put this into practice here, we're going to do a little bit more of filling in the blanks. 3 boxes. I like to make sure you copy all these down. The one on the far left has been done for us, but we still need to get that down as the example, and then we can learn from it and process it for the next ones. So 300,000, we could say, is the same as 3 times 100,000. And again, we've chosen that 3 because we've got to remember to get that number between 1 and 10. And 100,000 could be written as 10 to the power of 5. So 300,000 as standard form would be 3 times 10 to the power of 5. I'd like you to pause the video and see if you can have a go following that same method there to have a go at the other two. Far right one, I've given you very, very little help on that. Okay, so hopefully you had a go at those, and we should get 6 times 100,000. And then 100,000 again could be written as 10 to the power of 5, so that's 6 times 10 to the power of 5. Next one, again, we need the number between 1 and 10 first. We'd take the 7, and that would be 7 times 10,000. 10,000, be very careful, would be 10 to the power of 4, so that is 7 times 10 to the power of 4. So, what is 1.35 times 10 to the power of 4? Calculate it as 1.35, and we know 10 to the power of 4 is 10 times 10 times 10 times 10. And as you see in the previous slide, that's 1.35 times 10,000, which is 13,500. But it may be easier to think, looking at that power, the number 4 in the top right there, 10 to the power of 4, is about moving the decimal point 4 places to the right. So you take your 1.35, and each arrow there, I've simply moved the decimal point 1 to the right. And each time you move it to the right and there's no more numbers, you add in that 0. So it goes 135 point. Then we've moved it one more, so we bring in a 0, 1,350 point. Okay. And this is how we're going to have a look at doing some for ourselves. So again, I'll put the teach section down, you copy them into your book, and then I'll give you a chance a moment to do the do. So 3.45 times 10 to the power of 6. That 6 tells us we're going to move the decimal point 6 places to the right. Move it once, 34.5. Again, 345. And then we still need to move it 4 more. So that's going to add on 4 zeros on the end. And we'll get, nice and neat there, 3,450,000. Okay. Next one, 8.9 times 10 to the 3. The 3 tells us move the decimal point 3 places to the right. 1 place would take us to 89. 1 more place, 890. 1 after that, 8,900. And the final one, hopefully we're starting to get the hang of it, times 10 to the power of 4 is going to be move the decimal point 4 places to the right. Okay, and that will leave you with 76,320. Okay, so I'm going to pop up the do section for you now when you've copied those down, and you're going to have a go at doing the same thing for those 6 for me. Okay, so just write them out clearly in your book and have a go at those, and I'll put up the answers in a moment. Okay, answers for these ones are appearing there, so if you can just mark the work for me and put any corrections in that you need to do. So let's now have a look at perhaps going the other way. I'm going to give you the ordinary number and we're going to work backwards to put it into standard form. Again, key principle for the whole of this lesson is the first number that you're putting for it must be between 1 and 10. So 87,000, first thing you take from that, we can't use 87 because that's greater than 10, so we'll need to put a decimal point and have 8.7. Greater than 1, less than 10. And we would need to times that by 10,000. Okay, and then we can see on the last one to double check that we'd be moving 8.7, the decimal point 4 places to the right to get us back to the 87,000. Now you may choose on these answers to actually go in the reverse. So if we know we're doing 7.6 times 10 to the 5, is how many places have you moved the decimal point to get it to 7.6? Okay. So for the first one, we will have moved that 5 places. It is the equivalent of doing 7.6 times by 100,000. Okay, 100,000 lots of 7.6 times 10 to the power of 5, that would then become. 5,420, again, if you think of putting the decimal point at the end there, so 5,420 and then the decimal point, how many places do you have to bring that in? We're going to go with 5.42 as our first point. 5.42, that's where we need to get the decimal point to. We're going to move that in. If we count them across, one gets us after the 2, another one after the 4, then to the 5. We've moved that 3 places in, so it's 5.42 times 10 to the power of 3. Last one, 561. Again, might be useful to write it down as 561 point and just leave the point there. We want to get then the first number between 1 and 10. 5, again, 561, way too high. 56.1, too high. 5.61, perfect. How many places have moved the decimal point to get to 5.61? We've gone to the left twice, so it would become 5.61 times 10 to the power of 2. And then, like I say, that's when you can double check going the other way. 10 squared, 10 to the power of 2. That 2 means move the decimal point 2 places to the right. 5.61, 2 places to the right, gets us to 561. We know we're right, we can double check there. Okay, so once you've got those written down, again, you're going to do the do, and I'll put up some answers for you in a moment. Okay, well done, having a go at those. Answers are appearing now. And again, if we can just mark the work there for me, fantastic. Okay, next up. These two appear to be nameless. Usually we get names for these, but either way, we've got 2 pupils here who have put up some suggestions here. So what looks like the boy has suggested is 5,000 is the same as 5 times 10 to the 3, and 6,000 is 6 times 10 to the 3. Okay, and then the girl has then come in suggesting that 5,500, knowing it's midway between 5,000 and 6,000, therefore would be 5.5 times 10 to the 3. Okay, so hopefully again this is just some recognition that you're seeing the pattern that's emerging here. So how would 5,200 be written in standard form? Okay. We would be looking here then for 5.2 as our starting point times 10 to the power of 3. 52,000, we still need to take the 5.2, okay, because that number must be between 1 and 10. So we do 5.2, but this time we've gone another multiple of 10 higher, so we need 5.10 times 10 to the 4. That decimal place has moved 1 extra position, 5.2 times 10 to the 4. And then we know, right, 5.2 times 10 to the 6 is an ordinary number. That's 6. The power of 6 tells us the decimal point on 5.2 will move 6 places to the right and become 5,200,000. 5,200,000. Okay. I'll suggest as well, it's often a lot easier if you put those zeros in groups of 3 and put some commas in there, so you can clearly, it makes it a lot easier to read a number out there. The zeros tend to merge in as one on a screen when you can see them. Okay, so next up, another lovely fill in the blanks. This time we've got 40,000 is equal to 4 times 10 to the 4. You're going to fill in the blanks where they are there to tell me either the ordinary number or what it would be in standard form. Okay, so answers are appearing in there now for you. We should get 4,000, 4 times 10 to the 2, 420, 4.25 times 10 to the 2, and the last one, 4,250. Okay, a few more interesting facts then about astronomy. We're going to be told Neptune is 2.8 billion miles from the Sun. I would like you to have a go at writing this number in standard form. Now, just remember from the Do Now task, you should have now written in your books how many zeros there are in a billion if you weren't sure already, and then see if you can write that into standard form. And then for a bit of a bonus mark there, write 2.8 billion miles, put that into kilometres. Okay? And just for a little hint there, 1 mile is equal to 1.6 kilometres. So hopefully we'll have to go at the first part, and we should end up with 2.8 times 10 to the power of 9. To convert it to kilometres, we'll then need to multiply that by 1.6, and we would get 4.48 times 10 to the 9 kilometres. That's how far away Neptune is from the Sun. Okay, another way where we can see some standard form in real life is here are some African nations, and the populations are written on the right-hand side. I'd like you to tell me which of these countries has the largest population, and then when you've done that, write this number down as an ordinary number. Okay, so once again, pause the video and have a go at that for me, please. Okay, so the one that has the largest population, it's not the country that you'd possibly have, some may have gone with Kenya because of the 3.2. You need to look at the power for the 10, and the one with the largest one there is Nigeria with an 8. Okay, so Nigeria would have the largest population. I think I've tried to draw an arrow on the screen to show where that is in terms of Africa. That is Nigeria. Okay, and to write this number down as an ordinary number, we'd end up with 140 million. So Nigeria has a population of around about 140 million people there. I think as a country, United Kingdom is around about 70 million. So Nigeria's got around about twice the population of us here. And then which country has the smallest population? Smallest population. So again, now we're looking for the one that's got the lowest power. So we've got two countries, the Gambia and Swaziland, that have both got a power of 6. So those are our two smallest ones. If they've got the same power, then we look at the number in front of it, which is a 1.4 and a 1.2. 1.2 is obviously then the smallest. So Swaziland with 1.2 million, 1,200,000 as their population. Okay, and then another arrow is going to appear, and that is where we're looking at Swaziland, right sort of near the bottom there, just on the edge of South Africa. Okay, non-standard example here then. So I'm going to read this out for you, and I want you just to have a little think and see if you can spot what mistake has been made. So Leanne and Barney both know that a light year, and that's described as the distance light travels in 1 year, is given by, now this is going to test me, 9,461,000,000,000,000 metres. Now, that obviously isn't a very good way to write numbers down. Like we said before, mathematicians are efficient. We're going to write that better And Leanne has suggested that a better way to write this is in standard form as 9,461 times 10 to the power of 12 metres. Barney says that she is wrong and this is not correct standard form. What mistake has Leanne made and what should the answer then be? Okay, so I want you to pause there and see if you can find the mistake and then correct it yourself. So, hopefully we've realised, as I've said a few times in this, standard form must be in the form of a times 10 to the power of n, where a must be greater than or equal to 1 but less than 10. Leanne has suggested 9,461 times 10 to the 12. That is not standard form. It must be between 1 and 10. So instead, we would need to do 9.461 times 10. But then this time, because we've had to move the decimal place 3 more, we'll add that onto the power and get to 15. So in fact, we should have 9.461 times 10 to the 15 metres. Okay. Now we're going to have a bit of practice of converting what sort of looks like standard form, like Leanne has produced there, but then correcting this. Okay. Again, actually, sorry, one final one. What would this be in kilometres? For those who aren't quite sure of the conversion, your hint is there are 1,000 metres in a kilometre. Okay. So that one we would need to do is we would divide by 1,000, because there are 1,000 metres in a kilometre. So to convert that, we divide by 1,000. That reduces the power on the end and gets us 9.461 times 10 to the power of 12 kilometres. Well done for anyone who managed to work that out. Okay, so as promised, we're going to express each number in standard form now. So this is just slightly correcting what we've got here. 900 times 10 to the 6, we know is not standard form because the 900 is not between 1 and 10. Okay, so what we've got suggested on the right-hand side in this speech bubble, 50 times 10 to the power of 5 is not in standard form. Okay, so we could rewrite 50 times 10 to the 5 as 5 times 10 to the 1 times 10 to the 5, because we've had to shift that one more, so we need to multiply 5 by 10 to get to the 50. Then we've got the original 10 to the power of 5. We know with our rule of powers we'll add them, and that would become 5 times 10 to the 6. So if we look at that first one, 900 times 10 to the 6, we're going to need to instead have 9 times 100 to make the 900. Then we multiply that by 10 to the power of 6. 100 can be written as 10 squared. We've still got the 10 to the power of 6. So it's 9 times 10 squared times 10 to the power of 6. Add those together, 10 to the 2 times 10 to the 6. We're adding the 2 and the 6 for the power, so it's 9 times 10 to the power of 8. Okay. Next one, 77. We're going to need to do 7.7 times 10, then times by 10 to the power of 5. That becomes 7.7 times 10 to the power of 6. The third one, we need to go a little bit different. We've got 0.7 times 10 to the power of 3. Okay. So for this one first, we're going to need to get that to be a whole number, which would be 7 as our starting point. But this time we've gone the other way with our decimal place, so we would in fact reduce the power. Okay. And in that case then, we're going to need to do, it would be 7 divided by 10, then multiplied by 10 to the power of 3. So we're going to reduce it, because we're dividing this time, we'll reduce the power by 1. Okay. And that makes it 7 times 10 squared. Now appearing on the screen should be, yes, there we go, some examples for you to have a go at. So you're going to convert 30,000 times 10 to 3 into correct standard form and have a work through on those 8. So if you pause the video there for me, that will be the, I believe, the last 8 questions that we're going to go through on this PowerPoint today. Okay, just make sure as well you've got those examples written down. Hopefully you had a good go at those. And if you can mark those for me now, that should be what we're getting as our answers. Okay, yep. At this point then, there should be a worksheet that accompanies the PowerPoint. So if you just want to have a pause there for me and work your way through the worksheet, and there will be an answer sheet in there but don't look at that until you've had a go at all the questions. So if you pause it, have a go at those, and then come back to me, and we'll finish with a last bit of true or false together. Okay, so once again for true or false, I'll read out the statement. Unlike you once I read it out, just then to pause, suggest whether it's true or false, and where you suggest false, why is it false, and perhaps what would be the correct answer. So first one, 9.987 times 10 to the 3 is not in standard form. Is that true or is that false? Okay, that is false. That is in standard form. There's nothing wrong with that at all. That first number, the 9.987, is between 1 and 10, so that is in standard form. Second one, 32 times 10 to the 3 is the same as doing 3.2 times 10 to the power of 2. Is that correct? That's very similar to the questions we've just done, so you may want to rewrite that and see if that is correct. Okay, that is false. So if you look at that one, what have we done to the 3.2? We're going to need to do 3.2 times 10 to get to the 32. Then we still do times 10 to the power of 3. So we should have increased the power by 1 rather than decrease. So that should be 3.2 times 10 to the power of 4. Third one, is that the correct way to write 4,786,500 as 4.7865 times 10 to the power of 6? That one is true. If you move the decimal point 6 places to the right, because it's to the power of 6, then that will be what you'll end up there with, 4,786,500. Next one. Standard form is only an estimate of the real answer. That is false. Okay. Standard form gives you exactly the answer you're after. It's shorthand and it looks a lot simpler, but it is still exactly the same number there. You can put as many decimal points as you want on. So we've got 4.7865 on the one before. There's no limit to those decimal points. You can put as many as you need on it, as long as it's between 1 and 10 still. Next up, the index of 10 says how many places to move the decimal point. Now I may have given that away a little bit from my answer a second ago, so hopefully we can get this right. It does indeed. That number, like we said, 4.7865 times 10 to the power of 6. That 6 tells you you're going to move the decimal point 6 places to the right. Okay. And the last one, 5.172 times 10 squared is 517.2. Is that correct? Yes, it is. We're moving the decimal point with 10 squared 2 places to the right. Shift that along from 5.172, we get 517.2. Okay, and that concludes the lesson for today. So make sure you have completed that worksheet. And again, double check on the Heggerty that has been set for you online. And then there will be one more lesson to finish off for the week. So until then, take care, Year 8, and speak to you again soon.